Hello everyone. Previously we had discussed on the binary search variants, nothing but the lower bound and the upper bound, right? So this one, algorithm. So now today I will be discussing on the topic this one, binary search on rotated array algo, right? So let's get into the definition part first. So let's see what it states. So here binary search on a rotated array finds the target value in the sorted array, right? So this is very important. It on a binary search on the rotated array, what it does, it finds the target value in a sorted array that has been rotated, right? So that has been rotated or the shifted at some pivot, right? So this is fine. It uses the modified binary search. Again, it uses a modified binary search at each step, determine which half is sorted and decide which half can possibly contain the target, right? So again, it uses modified binary search. At each step we have to determine which half is sorted and decide which half can possibly contain the target. So this one will come to know when we write the code of the algorithm, right? So this is fine. Let's go with the explanation part here. So first, a rotated sorted array looks like this one. This is fine. See here, we have 4 5 6 7. This is sorted 4 times, right? So it has to be 0 1 2 4 5 6 7 basically. So 0 1 2 is at the end, so we don't have 3, don't get confused. So after 2 we have 4 5 6 7. So basically this is sorted 4 times. I mean this is rotated 4 times, right? So 0 1 2 4 5 6 7 it has to be, if it is sorted in the ascending order, right? So 0 1 2 4 5 6 7 it has to be, but 4 5 6 7 it is given at the beginning itself, meaning it is sorted 4 times here. This is fine. So a rotated sorted array looks like this one, originally sorted but rotated at pivot between 7 and 0, right? So this one between 7 and 0. Standard binary search fails here because the whole array isn't strictly sorted. So we can apply the binary search whenever the array is sorted, either in the ascending order or the descending order. We know this one, right? So standard binary search fails because the whole array isn't strictly sorted here. What is the trick then? So at every step we will check whether the left or right half is sorted, right? So meaning we will compare nums of left and nums of mid, right? So nums of left and nums of mid. This is fine. If the left half is sorted, if the left half is, this one is very important, the same thing will be implementing in the form of code or articulating in the form of code, right? If the left half is sorted and the target lies inside the sorted array, then we'll be searching the left. Otherwise we'll search right, right? So we will mirror the logic if the right half is sorted. The same thing, we will mirror the logic if the right half is sorted, right? So this keeps the search big of login for the arrays without duplicates, right? So this is fine, man. So this is the explanation part. Next, what we'll be doing here, let's do one thing. Let's go with the coding or the algorithm part. So let's go with the this one, search rotated function. So I'll just go with def search this one rotated here. So let me pass the parameters here, nums and target. So this is fine. So within the search rotated function, let me initialize left to 0 and also let me initialize right to length of nums. So this one minus 1. So this is fine, man. Now let's do one thing. Let's go with the standard binary search loop condition. So this is simple. So I'll just go with while left less than or equal to right. This is fine. We are just going with the standard binary search loop condition right here. So this one has to be, yeah, while left less than or equal to right. This is fine. So why this is screaming here? Oh, this one, let me give you length. Why I have given this one? Or right I considered here. This one left, where did it go? Left, this one, let me initialize this one to the 0, right equals length of lumps, this one minus 1. Yep. Let's continue. I don't know what happened. Yep. Let's continue. So here we are going with the standard binary search loop condition, right? So we'll continue while there is a valid range, basically. That is the reason we are going with the while loop. So next, let's calculate the middle index, nothing but the integer division. This one will be mid equals left plus right. So this one by 2. So this is fine. The next part would be, let's go with a direct hit check. So this one will be if nums of mid, so this one equals target, so then what we will do, will return mid. So I'll just go with a return mid. So this is fine. The next part would be, we have to design which half is sorted. So I'll just go with the if condition. If nums of left, this is fine, is less than or equal to nums of mid, then we have to check if the target is inside the sorted left half. So I'll just go with the if condition. If nums of this one left less than or equal to target less than this one nums of mid, in simple terms, right? So then the target is in the left half and we have to move the right pointer ahead, right? So this one will be right equals mid minus 1, simple. Else, so else target is not in the left half, then we have to move the left pointer. So this one will be left equals mid plus 1. So this is fine, man. We are done with this part. So we'll be going with one more else here, the main else, this one, right? So else, we were checking if the target is inside the sorted left half or not, right? So this one, basically not this one, basically we were deciding which half is sorted. So now otherwise we'll be going with the right half, right? So we'll be we went with checking if the target is inside the sorted half. Now else we otherwise we'll be going with the right half, basically from mid to right. So this must be sorted, basically, right? So simple. So this one, let's go with simple if condition. If nums of mid, if it is less than target, so less than or equal to nums of right, so this is fine, then target is present in the right half and we'll be moving the left pointer, basically, right? So this one will be left equals mid plus 1. This is fine. Else what we'll do, so we will go with the target that is not in the right half, so we'll be moving the right pointer. So I'll just go with right equals mid minus 1. So this is fine. Yep, this is fine. Let's do one thing. So we are in the while loop, right? So this is fine, man. So finally, if we exit the loop, target is not found. Target was not found, basically, right? So for indicating target not found, so let's return something. I'll just go with return minus 1, right? So this is fine, man. So we are done with the algo. This is the algorithm or the code. So this is simple, right? So let's go with the example usage. Right, so I'll just consider array here. So let's consider same array. During the explanation I considered, right? So this one will be 4 5 6 7. So let me go with 0 1 2. So this is fine. Now let's go with the print, just for the interactive purpose. Let's just display the array initially. So I'll just go with array. So I'll just didn't give comma, I think, here. This is fine. Let's go with one more print here. Search, this one 0. This is also fine. Yep, this one will be search rated. Let me pass array comma 0. This is fine. Again I'll just go with print here. So this one will be search, this is fine, 3. This is fine now. Search rotated, so this one will be array comma 3. This is fine. Yep. So let me go with array 2 here. I'll do one thing. I thought of copy pasting. This is fine. Let me type here. So this one, let me go with 1 2 3 4 5, right? So this is fine. So let me go with print again. So this one is second array, right? So I'll just go with the array 2 here. So let me pass, initially let's display only array, so I'll just go with the, again I didn't give comma I think, so yeah, so let me give array 2 here. Finally, after printing the second array, so we have to go with the expected index 3, right? So 4 at the position 3, so I'll just go with here print search 4, this is fine. So let me go with the function, let me pass the function search rotated here, let me pass array 2 along with the 4, so this is fine I believe. So output that we need to get here is, first we are displaying the array, first we are just printing the array, sorry, this one has to be 4 5 6 7 0 1 2 itself, right? So search 0, we are searching the 0 basically, right? Where the 0 is present basically, so see here 0 1 2 3 4, right? So we are searching 0, so it is present at the index 4, this one, right? So when we are this one, when we have called the function here, so we need to get 0 to 4 basically, right? So this is present at the 4th index, so we have to get 4 here. And next we are searching 3, where is 3 present here? 3 is not present at all, right? So as 3 is not present, we are returning -1 if the element is not found in the array, right? So we have to get -1 for this one, right? So for the first one, we have to get this one, for this one we have to get 4, the line number 41, for the line number 42 we have to get -1, right? 4th index and -1, because element 3 is not present, what we are searching for basically. So this one we have the correct sorted array 1 2 3 4 5, 0 times this one, what do we call, it's not rotated here, we have the straight elements, this one, right? So 1 2 3 4 5, so array 2 we have considered here, we are searching for the 4, so this is present at the 3rd index, right? So we have to get the this one, search for this one 3 basically, right? So this is the output that we need to get here. For this one 4th index, we have to get the output 4, for this one we have to get -1, and for this one we have to get basically 3, right? So let's check the same. I'll just try to run the code. Let me give Ctrl J here, press Python, let me right click, copy this one, paste this one dot py. See here, array, we are just displaying the array 4 5 6 7 0 1, this is fine. Search 0 to 4, so this one, right? So this is present, we are searching for the 0 basically, 0 is present at the 4th index, we are getting the correct output, right? So next here, search 3, we are searching for 3, 3 is not present in the array at all, see here, so we have to get the -1, so we are returning -1 if it is not present, right? So this is fine. Now let's come to the second array. We are just displaying the array here 1 2 3 4 5 array elements, right? So this is fine, 1 2 3 4 5, we are searching for the 4 which is present at the 3rd index, see here 0 1 2 3, 0 best indexing, right? So this one we are getting 3, meaning 4 is present at the 3rd index. So this works, algorithm whatever we have written works absolutely correct, right? Absolutely correct. So this is it for the binary search on rotated array. First we discussed on this one, binary search variants, nothing but the upper bound and the lower bound. Now we have successfully discussed this one, binary search on the rotated array, right? So yep, we are done with the algorithm part, right? So let me summarize whatever we have learned so far, right? So our problem is we have to find the just try to remember these points whatever I say now. So we have to find the target in a sorted array that was rotated at some pivot, right? So this will be the problem basically, right? So what is our key idea? This one, in each binary search step we will be determining, or we have to determine which half is sorted, then check if the target lies there, otherwise we have to search the other half. Simple, right? So what would be the result? This works in big of logarithmic n for the arrays without duplicates, right? Constant extra space, and is easy to implement and fast in practice. Just remember this one, right? So yep, this is it. So just remember these 2 points, man. Mainly what we are finding, we have to find the target on the sorted array that was rotated at some point. What is the key idea? In each binary search step we have to determine which half is sorted, then check if the target lies there, otherwise search the other half, right? So this is fine. Finally, what will be the result? So this works on big of logarithmic n for the arrays without duplicates. Just remember this one. You might forget this. I forget this one many times, so I'm stressing this one. This works on big of logarithmic n for arrays without duplicates, right? Along with a constant extra space, and it is easy to implement and fast in practice. Yep. So this is it for the binary search on rotated arrays, right? So previously we had discussed the binary search variants, right? So this is fine. Now we are done with this one. We are done with binary search on rotated array algorithm. Next we'll be discussing on the this one, ternary search algorithm, right? So we are left with only two searching algorithms. One is ternary search and another one is the last one would be exponential search, basically, right? So next we'll be discussing on the ternary search algorithm. For now, this is it. Thanks for watching, guys.